Hello, myself H.K. Bhangade, Department of First Year Engineering, SMD College of Engineering and Research Center, Evla. I welcome you in the video lecture series of Basic Electrical Engineering, a course of First Year Engineering. So we are discussing about the batteries. It is a part 2 where we discuss the different types of the batteries. So there are several types of different primary cells in use today. So the common ones are carbon zinc dry cell, alkaline cells, zinc chloride cells, mercury cells, silver oxide cells. So one by one, we'll discuss each cell in detail. So let us first discuss about the carbon zinc dry cell. So it is one of the primary cell, and this is one of the most popular primary cells often used for type AAA, A and CD. The negative electrode is made of zinc here, and the positive electrode is made of carbon, and that's why its name is carbon zinc dry cell. The output voltage of a single cell is about 1.5 volt. So this type of cell provides you 1.5 volt at the output. The performance of the cell is better with intermittent operation. Next is the alkaline cell. It is one of the primary cell. The alkaline cell is another popular type used for type A, C and D. It has the same output as that of the carbon zinc cell, that is 1.5 volt output it provides, but they are longer lasting. So the carbon zinc cells output and alkaline cells output are same, but the difference between both is that the alkaline cell provides the long lasting output. So it discharges slowly. Then it consists of a zinc anode and magnesium dioxide as a cathode in an alkaline electrolyte. The alkaline electrolyte is a potassium hydroxide. So what it consists? It consists of a zinc anode and magnesium dioxide cathode, and that is inserted in alkaline electrolyte of potassium hydroxide. So it works with high efficiency even with continuous use due to low internal resistance. So why its efficiency is high? Its working efficiency is very high. Even with continuous use, though we are using it continuously, it provides a maximum efficiency due to its internal resistance is very low. Its internal resistance is low, that's why efficiency is high. Next type of primary cell is a zinc chloride cell. The zinc chloride cell is also referred to as heavy duty type battery. It is a modified zinc carbon cell. It is the modified version of zinc carbon cell, and it has a little chance of liquid leakage because the cell consumes water along with the chemically active materials. The cell is usually dry at the end of its useful life. That's why there is no leakage possibilities. Next common type of a primary cell is mercury cells. So these mercury cells consist of a zinc anode, mercury compound cathode, and potassium or sodium hydroxide as an electrolyte. It is becoming obsolete due to the hazards associated with proper disposal of mercury. So somehow it is hazardous associated with proper disposal of mercury. Mercury, it consists of mercury. So silver oxide cells, next is silver oxide cells. So these cells consist of a zinc anode, silver oxide cathode, and potassium or sodium hydroxide electrolyte. It is typically available as 1.5 volt miniature button form. It is a button form silver oxide cell, and it provides 1.5 volt. Applications include hearing aids, cameras, your digital watches, hand watches, wristwatches. So these applications are the hearing aids, and that's why it is used in a button form. It is a button form. Its size is very small, and that's why it can be used in hearing aids and cameras and wristwatches. Next type of the mercury cell is lithium cells. This cell offers high output voltage, long shelf life, low weight, and small volume. It comes in two forms of 3-volt output in widespread use. It is lithium sulfur dioxide and lithium thionyl chloride. So in such a two forms it is available. So lithium sulfur dioxide type batteries contain methyl cyanide liquid as a solvent. If its container is punctured or cracked, it can release toxic vapors. So that is the drawback of this lithium sulfur dioxide cell. The safe disposal of this cell is critical. So the disposal of this cell, type of cell, is very, very critical. This cell is widely applied type of secondary cell used extensively in vehicles and other applications requiring high values of load current. So wherever there is a high load capacity is there, high load current applications are there, just like your vehicles, right? So such a type of cells are being used. So the positive electrode is made of lead peroxide. The negative electrode is made of spongy lead metal. The electrolyte is sulfuric acid. The output is about 2.1 volts per cell. And cells are typically used in series combinations of 3 6-volt battery or 6 cells for 12-volt battery. So that depends on how much volts battery is that. So depending on that, number of cells are either increase or decrease, and they are in series. And also the current capacity, as the requirement, they can be taken as a parallel combinations also to increase the current capacity, load bearing capacity. The next is in the secondary battery, which is the next point to discuss about this battery, is used in vehicles, and they have a reversible chemical process. And whenever there is a reversible chemical process, they can be easily charged. So discharge, the battery reacts by producing current flow in an external load circuit and produces lead, sulfur, and water. So this reaction is a reversible reaction. And charging, the battery reacts to a reverse current from an external energy source and produces lead peroxide, and sulfuric acid. So while it discharges, it produces PbSO4 and water. While charging, it produces lead oxide and H2SO4. That is the sulfuric acid, lead peroxide and sulfuric acid. So like this, the charging and discharging is continuously going on. It is a reversible reaction. The current rating for this is lead acid batteries are rated in terms of how much discharge current they can supply for a specified amount of time. The ampere hour unit is used there. Generally, this rating is proportional to the physical size. In automobile battery that might have a 200 Ah rating, how long can this battery supply 20 amperes? So that time can be calculated by this formula: capacity upon load current. It is capacity is 200 Ah, that is ampere hours, upon load current maximum is 20 amperes. So it lasts about 10 hours. So the actual ampere hours delivered varies with battery age and conditions. Temperature and discharge rate, that also depend for the discharge time. In specific gravity, the specific gravity is a ratio that compares the weight of a substance with the weight of water. The states of discharge, how much charge the battery has left, is checked by measuring the specific gravity of the electrolyte solution. So one cell of an automobile battery is shown here. So it is there, PbO2. As the cell discharges, more water is formed, lowering the specific gravity of the electrolyte. And when it charges, that time water level decreases. So this is discharge process. Okay. During that, what happened? The Pb plus PbO2 plus 2H2SO4, and that gives you 2 PbSO4 plus 2H2O, means water level increases during the discharge. Then the charging lead acid batteries apply about 2.5 volt per cell. उनको चार्ज करने के लिए हमें क्या करना है, पर सेल हमें 2.5 वोल्ट उसको देना है. If 10 cells are there, then you have to give 25 volt total. So attach the terminal of the battery charger directly to the corresponding terminals of the battery. Positive terminal to the positive terminal of the battery, negative terminal to the negative terminal of the battery. So this process restores the battery's ability to deliver current and voltage to a load. So this is a charging process. According to the number of cells, we have to provide the corresponding voltage to charge. And this connection is very simple. For the positive terminal of the battery, connect the positive terminal of the charger. Negative terminal of the battery connect to the negative terminal of the charger. So charging an automobile battery, one cell shown here. So the charger produces 2.5 volt, about 15 volt for a 12 volt battery. 12 volt की बैटरी के लिए हमें 15 वोल्ट यहाँ पे देना है. तो ये चार्जिंग प्रोसेस है, यहाँ से चार्जिंग शुरू हो रही है. तो ड्यूरिंग चार्जिंग व्हाट हैपन, एज द सेल डिस्चार्जेस मोर वाटर इज फॉर्म, लोअरिंग द स्पेसिफिक ग्रेविटी ऑफ द इलेक्ट्रोड. और चार्जिंग होते टाइम क्या होगा, पानी की मात्रा यूज होगी 2 PbSO4 plus 2H2O. इट फॉर्म्स द Pb plus PbO2 plus 2H2SO4. So this is charging of an automobile battery. So this is all about the types of the batteries and the charging of the battery. So thank you. In next lecture we discuss about the next topic in the battery. Till then, thank you.